Hello and welcome back. We're going to get started, jump right in to JB Lorenzo's talk about Jetpack benchmark. And with that, let's kick it off. Don't forget to put your questions in the Slack channel. And yeah, let's get going.
Hi, everyone. Hello from Berlin. Hello, everyone watching online. I'll start by sharing my screen. So I'll be discussing about measuring what matters to us with Jetpack benchmark. I work at OLX in Berlin, and we handle several OLX apps existing across Europe and some in Central Asia. When we read app reviews, sometimes we see things such as this: lags, notifications not working, or they are bored with the lags. By the way, this is brought by AppBot, a tool online we use, which categorizes the reviews via topics. So this is the performance topic. And this one has quite a weird translation. There are lags, but they fight. It's from the Ukrainian app. And I was told this means that we're trying to resolve the lags. And this is more reviews about lags in Romanian, cannot access the browser without lag. Sometimes they try to be very specific, and also the translations are not so good, but you kind of get the gist that when you open the app, it lags very hard, and all the time it has connection errors, and sometimes it stops the application. And another one here is like really specific. I think this is a developer. So when the ads appear while scrolling, it makes the application very laggy. And so these are probably the Google ads we have on our feed. So some more kind of funny translations: infection to very infected. And I think this just shows that there are a lot of people who are frustrated about lags in our application. So how do we stop these lags? One way is to test, to profile before launching your application and make sure everything's running smoothly. Or you can also add instrumentation, such as Firebase performance, to measure how fast your screen is rendering or how slow it's rendering. Or in our case, we have New Relic, which is used to measure things such as interaction duration, which shows how slow or how fast you are interacting with each activity or with each screen. And another way for this is to prevent regressions on your performance. And the way to do it, one way to do it is you can use benchmarking. When you measure how fast your application is doing certain tasks, such as scrolling through your home feed or opening up an advertisement or sending a message to the chat screen. So if you measure how fast these tasks are performed on a device and you push, you compare it against a threshold value, and then if you have enough of these values, you can make an analysis to check if you are regressing with your performance. So with benchmarking, you can generate stable enough values so that you can do the check for regression. So Jetpack benchmark has been released last year in beta 1 on October, and also on RC1 on October a few days later. And lastly, the stable version has been released November last year. And if you don't know, it has only been released May 7th of last year with the first alpha version. So it looks like the development of this tool is really, really fast. And I saw another version, 1.1, and the original author of this, he told me that there's more coming in that version. So if you want to see more, watch out for the next version. How it works is just a summary. I took this photo from a blog that I read. It's a very nice photo. It first warms up the application or your device so that it's in a state where every time you run the measurements, it's the same state. So it prevents going into a mode where the device is running on low power mode or slowing down or being interrupted by other applications. Or for example, if your battery is low, it prevents that by giving you a warning or stopping the measurements entirely. So once it warms up, it performs the measurements and then afterwards it shows you the results or collects the results and then gives you a file. So from that stage of the warm-up, it has several improvements that I'm probably not going to go through, but I'll show it here. But one of the most important things here is, for example, this undetected clock frequency. So when your phone is running, it has the clock, which is the gigahertz of your phone. There was a bug detecting the clock frequency and led to an unstable benchmark result. And there's another one about garbage collection on each warm-up to reduce the leak. So this is just all overall improvements on the warm-up, and also more improvements such as disabling test coverage, which gives you a slower result because test coverage adds a lot of other things that it's running, and other couple of things that I'm not going to go through. They've also documented recently how to run Jetpack benchmark in your CI. If you go to this link, you can read about it. And there's guidelines for running benchmark without Gradle, using a self-instrumented APK or separate app and test APKs. So this second method is what we use to run it later. I'll discuss it later. And some important flags for CI, such as locking the clocks of the device you're running against. And if you want to get the JSON output, it's also documented there. I will show it to you later how to use that. So let's begin. What do you need to do when you write benchmarking for your code? There's several steps. First, you want to add a benchmark module to your project so that you can run benchmarks. And then you need to put your code that you want to benchmark in a separate library because benchmarking doesn't work on the main application. You can only run it against code that is in a separate library. And you want to write instrumentation test after you have the code already placed in a separate library. And then after that, after you tested it locally, you want to run it in CI, of course. And once you get the results, you want to detect regression. So we'll go through all of those. First, you want to add the benchmark module. These steps are also documented very well in the Jetpack benchmark page in Google. And I'll just show it to you again here briefly. So if you want to perform, if you want to add your benchmark module, Android Studio already supports it, I think 3.5 and up. There's already an option where you can add a benchmark module when you select a new module. And after you select that, it asks you for the name and the package name. And then after that, you've already added the benchmark module. I can just briefly show it here, how it looks like. It's here. So there's a benchmark module made by it, and there's also some files already, like this Android manifest file. It will already add the benchmark JUnit dependency here, as you can see, and also in the Android manifest file, you get something like this thing. So ignore the hard-coded debug mode. So when you run this, it will ignore this button. So because debugging does not give a stable value for benchmarking. It also really tries to disable by the debugging by replacing the debuggable flag here using a hard-coded value. And if you see here, there's one more option that I added because I'm running sometimes on my device, which is an Android 10, to prevent using the new storage, the new way to use the storage. So this is just to run it the same way as we've been running it before. So now that you have the benchmark module, you want to put code in a separate library for benchmarking. One advice we can give you there is, because we face some challenges, is really try to modularize your code early on so you can benchmark it later. Or if you already have your modules, or if you don't have your modules yet, you have some code, for example, in your application module that you want to benchmark. One thing we've tried is we split almost everything from that app module into a separate library, and then just keep the bare minimum in the app. Also, you want to mock some of your things. So when you run a benchmark, you don't want it to access the network. You don't want it to access, for example, the shared preferences or the disk if it gives an unstable value for your benchmark. But most importantly, yeah, to get a stable instrumentation test similar to your normal instrumentation test, you want to mock the things that you use. So, for example, we face a lot of issues with Mock-K and Mockito. So you want to get ahead of that, or maybe you want to avoid using that altogether and just use dependency injection, for example, Dagger or Coin. In our case, we use Coin. And we also face some data binding problems. We use data binding in our project. And when I was refactoring some of the stuff outside to a different module, when I changed the package of the classes that are using data binding, it caused compilation errors. And one tip you can try there is to clear the caches. For example, in Gradle. So you remove the Gradle caches and then clean your project and then rerun it. And that should solve most of the data binding problems. So now that you've already tried to separate your code in a separate library, it's time to write instrumentation tests. So when you want to measure, for example, we have a sample project that doesn't have any other OX code. You can download it here, written by my colleague. We also wrote a tech blog about this. If you go to tech.olx.com, you can read the article about it. And again, going back to that diagram, the benchmarking tool for Jetpack does Warmup, and then it runs the benchmarks, and then it gets you the results. For example, here, this is one of the instrumentation tests that has benchmark. So it's very simple. So first, you wrap your code with benchmark rule measure repeated. And what it does is it performs the block repeatedly and performs measurements against it. So in this case, JSON parser parse sample 1 is being done repeatedly after the warm-up. And then it gets the measurements, how long it takes to run this code inside the block. And if you want to measure the UI, you can also do that. For example, here you have an activity rule. First, there's a UI thread test. It says that this test should be run on the UI thread and should not run it against a background thread. Prevents it from crashing, because if you want to, for example, scroll the recycle review, it might crash if it runs on a different thread other than the UI. So here we just set up the activity in the recycle view. Once you run the activity, get a fragment that contains it, and then gets the recycle view, so you can scroll it. And finally, you want to measure how fast it is to scroll this view with, for example, the advertisements that the users are complaining against. This is sample output of this. This command ADB shell and so on is documented in Jetpack benchmarks documentation, so I'm not going to go through all the parameters that we use here. And as you can see here, it shows a really nice output, but this is using the alpha versions of Jetpack, so I'm not sure if it changed the way to output these values. And so we plotted these values here very simply. So what we were trying to do was to determine which of our parsers were the fastest. We were using multiple ones. For example, all of these three were using Jackson, Kotlin serialization, and JSON. And we're trying to find the best one to choose so that we can just have one, because it's making our binaries really large, and we don't want that. So what we found was Jackson was the fastest, but also Jackson was the biggest binary that we have. So based on this graph, we also have Kotlin serialization in second place to be the fastest one. So we we thought that it would be a nice trade-off to use Kotlin serialization to have a smaller binary and a relatively fast JSON parsing performance. So these were all done by my colleague Mutaz. If you go to techolex.com, you can read about his blog article. So going back to the steps of how to perform benchmarking. Now you want to run it in CIs after you've written your instrumentation tests. There's multiple options that you can use. First, you can use Firebase Test Lab, or you can also use Amazon EC2 plus emulator, which might not work, but I will discuss it. Or if you have your own device farm, you can run your benchmarks against that. So first, let's go through Amazon EC2 plus emulator. It will not work because Amazon does not allow nested VM, and you need to run bare metal instances. So it's not so simple to run it, to run the emulator. And of course, it's not advised for benchmarks. And other cloud providers that has VM, nested VM support is, for example, you can do this there. But still, emulators are not so good for running benchmark as outlined here. So this is not a very good solution. So the other option, for example, is your own device farm. So if you have your own device farm, you can run it, the benchmarks, and then get a JSON output. So what you would get in that JSON output is this, and we go through them. First, since this is the context of your test where you ran it. So in this case, I ran it in an emulator, and which has the version API level 28. And the CPUs are not locked, and to stay in performance mode is enabled, or is not enabled. And yes, this is the device description, and then the benchmark results. So here you can see the name. There is emulator unlocked, and then the name of the benchmark. What it says is, these are the warnings. So if you run it in an emulator, it will append to your results, emulator underscore. Or if you run it in a device that has unlocked clocks, which is bad, it will also add a prefix. So here we're running in an emulator with unlocked clocks, which is not so good, but still we can run the benchmark. But if you don't do a step before this, you will not be able to run it. You need to suppress these errors. I'll show you later how it's done. So as I mentioned, it's running in an unlocked device, and sustained performance mode is not enabled. You can suppress these errors by adding a test instrumentation argument, either in the Gradle file or in the ADB command. So what I would advise here is put it in the Gradle file so you can add it in your repository, and then you can put the comma separated value without spaces of the identifiers here of the warnings. There are several of them. I'm not going to go through them. One of the things you can find there is if you have an engineering build of your device, it will also throw an error to you. And several other errors such as battery, unlock locks, as I mentioned earlier, sustained performance mode, if you have debuggable on, or if you have code coverage enabled, it will also throw an error to you. You can find all these errors in this path here in the Android source code in errors.kt. So going back to the solution, we found that Firebase Testlab is the best way to use it because we don't have our own device farm and an emulator doesn't just cut it very well. So how do you integrate it with Firebase Testlab? There's some caveats first. When we were running tests with the mock network, we had some problems. But then if you mock your network properly, this will not be a situation for you. So we fixed that. And then after that problem, you have a fee to use it after the feed here. And you need to configure Gcloud in your CI, which is not that hard. And you need to fetch the results in Gcloud storage. So this is the command that we use to run Firebase in Testlab, to run the benchmark in Firebase Testlab. So first you have Gcloud Firebase test and run, and then you supply the app APK. It doesn't really use it, I think, but you need to supply it anyway. And then you run, you supply it with the test APK. So this is the split APK method that I referred to earlier in this presentation. Then you select your device model, and then you specify which project in Gcloud you want to use and where to put the results. And then once you run the benchmark, you want to pull the results from a directory. So here we're just pulling it from SD card. And then very importantly, if you want to get the JSON output of your test, you can provide environment variables here. I read a blog which said like earlier in the year that you need to add a custom application to your benchmark so that you can specify this variable in a way that works, because this thing didn't work. But as I tested now, it works. So you can just get the JSON output from Firebase using this environment variable. And as you can see here, this is the JSON of the benchmark in Gcloud storage in the artifacts folder after you pull it from the device. So how do you actually run it in GitLab, as you say? This is the GitLab YAML configuration that we have. So we'll go through this. First, you want to generate the application so that you can submit it to Firebase. And then you want to generate the APK for the benchmark that actually runs the benchmarks. And then you want to send them to Firebase using the command I mentioned earlier. And then after that, you want to get the result. To get the result, you need to pull it from Gcloud storage. So you can use gsutil to fetch it from where you specified it should be. So in this case, cloud test tablets.pl or xpl. So this command just gets the latest one and then pulls out all the JSON files from there and copies it to this folder test result. That's why we made the directory in the first line, this highlighted comment. And then we want to get those results into the benchmark folder just so I can parse it later. might be an unnecessary step, but it's just to make it cleaner. So at the end, we want to process this JSON output because after you get the JSON output, you want to detect regressions. So in that script, that benchmark.sh script, just prints out all the JSON files in this benchmarks folder and passes it to the Python script, which processes the JSON output. So in this Python script, what we have is first you load the string coming from standard input, which is the JSON file, and then get the benchmarks part of the JSON, and then get all the averages on it. So after this, you will have a dictionary of the test names and then the median result of the benchmark. And then this thing is the one where you need to put the thresholds that you want. So you can run it like the first time and then get a result. And then put it here as your threshold. So here is the name of the test and with the threshold values. And this is in nanoseconds. And then for every threshold, you want to check the limit and the actual value coming from the JSON and check VS on threshold if it exceeds it. So this is a very simple way to detect regression. There are several other ways that you can use, but this is the simplest one that you can use. Have just a hard-coded value, and if it goes over that with some percentage, for example, you measured you're scrolling through your UI as 300 nanoseconds, and then if it goes 10% above that, like 330 nanoseconds or above, then or about 330 nanoseconds, then you print an error and then you exit. So you can stop the CI and say, okay, there is a regression. But this is not a very sophisticated way to detect regressions. You can use other things. And this is the output. As you can see, it's running when you run it on, it's scrolling the feed when you run it on Firebase. And also here, this one is randomly scrolling, and the other one is clicking on the advertisements. So going back to the example project, if you want to try it out, you can go to this URL and check out the sample project if you have. There's also a bunch of other issues in Jetpack benchmark. Even though it's stable, you can check out because we face some issues that have some solutions there. And again, I work at OLX. I have watched this original presentation by the authors. You should watch it to understand how it works internally, Jetpack benchmark. And then they also have a blog article about how to detect regressions in a more sophisticated way, more sophisticated than what we are using. Here in this article, you can find it out. But again, this is one of the building blocks of setting up benchmark. You can replace it with any other kind of regression detection that you have. So this is OLX. We operate in these countries with these brands, and we have offices in these areas. So if you have any questions, you can contact me here. And thank you very much for listening to my kind of short presentation. And have a good day, everyone. Bye.
All right, that was great. Just a reminder, for any questions that you have, we will be in the channel that you see at the bottom of the screen. Day one, JB Lorenzo will be doing questions async for this one. And while we're waiting for the next talk, that will be at the top of the hour. Feel free to go fill your drink, stretch your legs, visit the expos, and get ready for the next talk. And we'll see you all soon.